Hello learners, I am Dr. Subodh Kesharwani working with Indira Gandhi National Open University in the School of Management Studies. The topic which I am going to talk today is fundamental concepts and approaches to probability. This is part of our course called MCU3 Research Methodology in Statistical Analysis, and we are here with fourth block. And there are certain the chapters which comes under the ambit of the fourth block, which more focuses on the testing, probability and hypothesis testing. And we are here with the term called probability. So already we have a very preamble session, the curtain raiser to probability, and we are moving one step ahead and more talking about the concepts related to probability and what are the approaches to probability. So if you go more to the backdrop, you will find out there are three kinds of approaches, that is classical, experimental and subjective. So we will throw a light on that part with the help of certain examples, but prior to going into the depth of that, we just focus on the fundamental concepts. So if you talk more about the probability, life is uncertain and full of surprise. And do you know what happened tomorrow? Make decisions and live with the consequence. The probability of an event is a numerical value that measures the likelihood that the event can occur. So probability is the measure of the likelihood of a random phenomena or chance behavior. Probability describes the long-term proportion with which a certain outcome will occur in situations with short-term uncertainty. And what are the applications of probability? The probability theory is applied in everyday life, in risk assessment and modeling, the insurance industry, and market use actuarial science to determine pricing and make trade decisions. And if you go and talk more about what are the concepts of probability important and how it is quite important, the concept of probability is as important as it is misunderstood. It is vital to have an understanding of the nature of chance and variation in life in order to be a well-informed or efficient citizens. One area in which this is extremely important is in understanding risk and relative risk. Now, there are certain probability rules which we are going to exclusively cover in our coming sessions, and which focus more on the event. And there are probability rule 1, there are probability rule 2, there are probability rule 3, and there are probabilities involving multiple events. So probability rule 4 is more talking about additional rule for disjoint events, that is finding P, A and B using logic. And if you talk about rule 1, I think for any event, 0 is less than or equal to PA and less than or equal to 1. So the sum of the probabilities is all possible outcomes is 1. And we will talk more about this in a more elaborative manner in our coming sessions. So probability deals with experiment that yield random short-term results or outcomes, yet reveal long-term predictability. The long-term proportion with which a certain outcome is observed is the probability of that outcome. So when you're more talking about probability experiments, a probability experiment is an action through which specific results, counts, measurement or response are obtained. For example, rolling a die and observing the number that is rolled is a probability experiment. The result of a single trial in a probability experiment is the outcome. The set of all possible outcomes for an experiment is the sample space. So, and if you talk more about the example of this, the sample space when rolling a die has 6 outcomes, 1, 2, 3, 4, 5, 6. So now, since we have to give a brief about what exactly the concepts of probability is, we are moving ahead and talking more about the approaches for determining probability. And there are 3 approaches for determining the probability. And the first approach, which more focus on the classical approach, or we can say the classical method. Second is relative frequency approach or empirical method, and third is subjective approach or subjective method. So an event consists of one or more outcomes and is a subset of the sample space. And a die is rolled, event A is rolling an even number. A simple event is an event that consists of single outcome. For example, a die is rolled, event A is rolling an even number. This is not a simple event because the outcomes of event are 2, 4 and 6. So if you more go into the depth of classical approach, the classical approach to probability express probability as a ratio of the number of favorable outcomes in a series of successive trials to the number of total possible outcomes. Furthermore, all possible outcomes are assumed to be equally probably, and no 2 possible outcomes can both result from the same trial. So If you talk more about the classical probability, classical or theoretical probability used when each outcome in a simple space is equally likely to occur. The classical probability for event E is given by PE equals to number of outcomes in event divided by total number of outcome in sample space. Example is a die is rolled and find the probability of event A rolling a 5. So this outcome of event A is 5, and if we talk about the probability of event A is 1 by 6 equals to 0.167. So this is the way by which we are going to calculate the classical method. And if you talk about the experiment example given, flip of coin, outcome of head or tail is there, and exact outcome is unknown before conducting any experiment. All possible outcomes of experiment are unknown. Each outcome is equally likely. Experiment can be repeated under uniform conditions. Together these conditions produce regularities or patterns in outcomes. So what we have observed that this classical method is quite general method, and if you take some good examples, I think probability of two heads in two tosses of a coin is 1 by 4, then the value could be 0.250, and the probability of obtain 4 in roll of one die is 1 by 6, and the value is coming 0.167. And if you take another example like probability a total of 4 when rolling 2 dice, that is 3 by 36, that is 1 by 12 equals to 0.083. So if one randomly selects individual from a large population, that is half male and 1 by 2 female, then probability of one male and one female if two individuals selected is 2 by 4, which comes to 1 by 2, and the value is 0.50. And if probability of two females and one male if three individuals selected is 3 by 8, then the value could be 0.375. So this is called a classical method, and afterwards this relative frequency method is going to be applied. This is quite more experimental in nature, so that is the reason we usually call this as a experimental method also. So this method used for an experiment where it is not possible to apply the classical approach, usually because outcomes not equally likely or the experiment is not repeatable under uniform conditions. The probability of an event E is the relative frequency of occurrence of E, or the proportion of times E occurs in a large number of trials of the experiment. So what we have observed that example of relative frequency method is party supported, conservative, liberal and DP green, and the percent of support is 38, 27, 17, 9 and 8 respectively. If one meet an individual and know nothing about this person, the best estimate of the probabilities that the person supports the various parties are: P individual is a conservative supporter, so 0.38 is there. If individual supports the green party, it's 0.009. So by this way, we are going to estimate the relative frequencies to approximate probabilities, and the following data represent the number of homes with various types of home heating fuels based on a survey of 1000 homes, and approximate the probability that randomly selected home uses electricity as its home heating fuel, and would it be useful to select a home that uses coal or coke as its home heating fuel. So what we observe that when you are going to plot this in a tabulated format, I think house heating fuel is utility gas, bottle tank, electricity, fuel oil, wood, solar energy and other fuel, no fuel use. So frequency is 504 with respect to utility gas, 64 with respect to bottled, 307 related to electricity, 94 related to fuel, and solar energy 1, other fuel is this. So when you are going to calculate this, I think this is the way by which you are going to do that. So as an experiment is repeated over and over, the empirical probability, and there is law of large numbers. As an experiment is repeated over and over, the empirical probability of an event approaches the theoretical actual probability of the event. That is, Sally flips a coin 20 times and gets 3 heads. The empirical probability is 3 by 20, and this is not representative of the theoretical probability, which is 1 by 2. As the number of time the person tosses the coin increases, the law of large number indicates that the empirical probability will get closer and closer to the theoretical probability. So probabilities with frequency distribution, if you see the following frequency distribution represents the age of 30 students in a statistics class. What is the probability that a student is between 26 and 33-year-old? If we take our ages, 18 to 25 frequency is 13, 26 to 33 frequency is 8, 34 to 41 frequency is 4, 42 to 49 frequency is 3, and 50 to 57 frequency is 2. So if we take a summation of the frequency, it is coming 30. So the probability of age 26 to 33 is 8. So the probability is 8 by 30, which comes to 0.267. So this is the way by which we are going to calculate the frequency distribution probabilities with respect to the frequency distribution. Now, after talking more about classical approach and this experimental approach, the third way of doing it is the subjective probability. So subjective probability results from intuition, educated guesses, and estimates. A business analyst predicts that the probability of a certain union going on strike is 0.15. Range of probability rule is the probability of an event E is between 0 and 1 inclusive, that is 0 is less than or equal to probability of A less than or equals to 1. So this is called, if you see this 0 is impossible to occur, and PA is 0.5 which is even chance, and 1 is certain to occur. So this is what we have already discussed in our concepts of probability or in the preamble part of the probability. But since we are applying it, we see how this is going to be applied. So subjective or judgmental method is make your best guess of the likelihood of the event based on reliable information, good judgment. Inform yourself about the issue or discuss it with someone knowledgeable. Probability is number between 0 and 1 that represents your degree of belief the event will occur. And if you talk about probability of E which close to 0 implies a judgment that the event is unlikely to occur. So probability E close to 1 implies a judgment that the event is quite likely to occur. There are some more examples of subjective methods, and if you talk about like probability of particular thing is like one can defeat the other person, and the probability is 0.7, or probability have an auto accident during the next 6 months is 0.02. Some snowfall in particular area of Himachal or Kashmir before the end of October is 0.97. So these are some of the examples which is there. But on the other hand, there is a difference between subjective versus objective probability. Subjective probability is the probability in lay terms something is probable if it is likely. Example, I will probably get an A in this course. If you talk about objective probability is what we will use in the course. And if you take example, objective probability is a relative frequency with which something occurs over the long run. So what does that mean? So suppose we flip a coin and get tails, then the relative frequency of head is 0 by 1, which comes to 0. And suppose we flip it again and get tails again, our relative frequency of head is 0 by 2, which again comes to 0. We flip it 8 more times and get a total of 6 tails and 4 heads. The relative frequency of heads is 4 by 10, which comes to 0.4. And we flip it 100 times and get 48. The relative frequency of head is 48 by 100, which comes to 0.48. So this is one of the example of the objective probability. And we flip it 1000 times and get 503 heads. That the relative frequency of head is 503 by 1000, which comes to 0.503. So if the coin is fair and we would flip it in an infinite number of times, what would be the relative frequency of heads be? So it would be 0.5 or 1 by 2. So that is the relative frequency over the long run or probability of the heads. So now subjective probabilities are probabilities obtained based upon an educated guess. For example, there is a 40% chance of rain tomorrow. So I think we have talked a lot about all these approaches, which is quite important. And when we are taking some good examples, when in our coming sessions when we are going to talk about probability distribution or probability rules, I think we are going to apply these approaches. Either it could be the classical or experimental or this subjective. So by this I am winding up this particular session. We have 2 basic sessions which focus on the probability, and this particular session was more talking about the fundamental concepts as well as approaches to probability. So in our coming sessions we are going to take some numerical examples, or we can talk about certain rules which can build concepts of probability in a more elaborative manner. Thank you very much. Thank you.